inverse functions linear discrete? Let's start off thinking about a discrete function, f of x, and I'm going to present this function in a table. So if we have some x values and f of x values, a discrete function is a function that has just a couple of points on it. Perhaps x is 0, 1, 2, or 3, and f of x spits out 2, 5, 7, or 8. So in this case, for example, f of 2 is equal to 7. The inverse of a function remember, changes the direction that we discuss things. So instead of y equals f of x, sometimes you'll see it written as x equals f inverse of y. So if I want to evaluate f inverse of 5, I come over here to the column of y values, I find the 5, and I link it back here to the 1. In a linear function, say f of x equals 1/2 x plus 3, we can algebraically come up with an expression for the inverse. Right? Instead of calling it f of x, our graphs are usually y equals something, so let's look at y equals 1/2 x plus 3. And because we want to go from y equals f of x to x equals f inverse of y, our next step is to take this equation and solve for x. Right, the algebra is not too troubling there. I get 2y minus 6 equals x. Or, since x is f inverse of y, I can say this as f inverse of y equals 2y minus 6, and then simply changing variables back to the x, which is traditionally the thing that we take as the argument of the function. Just switch the y with an x, and I get that the inverse function here is 2x minus 6. If I want to evaluate at a particular point, I can do so from here. You could also, if you're just looking at points, evaluate each time individually, but I find that solving the equation like this is the faster way of going about it. So I get that the inverse, f inverse of 4 comes out as 2. And to double check that, I can come back up here and evaluate f of 2. And see that I do in fact get back to 4.